I'm Chris Dennis.
I'm Alex Snaps.
This is bringing javax, or javax, depending on how you say it, caching to your application, which obviously in this context means your Spring application. Sorry, Grooving Grails users. Who are we? I'm Chris Dennis. I'm a software engineer. I am not a Spring engineer. I work at Terracotta, which is now owned by Software AG. Or was, since it no longer exists now that the JSR is finalized, a JSR 107, which is the Java caching standard, expert group member. I was Software AG's representative.
And I'm Alex Snaps. I'm a software AG engineer as well. Work on the Terracotta stack, cache, Quartz, all that stuff. Show of hands, how many people are actually already using, how many people know about JSR 107? How many people are using JSR 107? And how many people are actually using caching, whatever vendor, whatever? All right, it's a handful. All right, how many people are using Hibernate in this room? Hibernate, yeah, you're around? All right. Okay, looks like this may be relevant to you all.
Cool. How many people use us for caching, by the way? How many people use cache? Good, thank you. So we've thrown a lot of words around. Terracotta, Software AG, cache, what the crap. So lots of people might have heard of Terracotta. We started out doing this thing called network attached memory, or distributed shared objects, or DSO. It was this magic technology that allowed you to cluster an arbitrary Java application. You just said everything beneath this object is part of the networked object graph, and it bytecode instrumented all your classes, and woo, clustering. It was really, really, really hard to use, and really, really, really hard to sell, and really, really, really hard to support.
But it was darn cool.
It was really fun to work on, for all the reasons that it wasn't fun to use. Because this thing was so hard to sell, we said, we need something easier to sell and easy to use. And we said, well, look, there's this thing called cache, and it has a huge community, and it's easy to use, and everyone needs it. And it looks like there might be a business in maintaining this thing and making it better and selling support and maybe selling some enterprise features. And so we bought this thing called cache, which is the world's most used Java caching API. We bought it in, as it says, August 2009. It really doesn't feel like it was that long ago, but it was. It was formerly a Greg Luck product. It was originally Easy Hibernate cache. It is our cache, our baby. We also bought this other thing not long afterwards called Quartz, which a lot of you use.
How many people know about Quartz?
Yeah.
Yeah, I see.
Cool, see. Both Quartz and cache are projects that when you work on them, you kind of forget how many people use them. Because a bunch of you just use stuff and it works, and you never talk to us and you never complain, which is nice, but fundamentally not very gratifying. We like to have our egos massaged. So we bought that not long afterwards. It's basically, for those that don't know it, it's a scheduler in the cron sense. It's like cron for Java. You want to run a job once every day, once a week. Last Thursday in July, it'll do it. Cool. And then, of course, big fish eats little fish, and then massive shark comes along and eats the fish. Software AG, which is the second largest software company in Germany.
In Europe, actually.
In Europe, yeah. Well, because Germany's big. After, obviously, SAP, who are enormous. They bought out Terracotta in May of 2011. And have integrated us heavily. So basically, if you use a Software AG product, I doubt many people in this room do, except maybe.
How many people do?
Yeah.
How many people use web methods already? Okay, thank you for showing up.
Cool.
I saw you.
If you use web methods, the two people in this room that use web methods, you are using cache, you just don't realize it. We are heavily integrated with all the rest of Software AG's products, but you can still buy support for these products for us directly. Cool. So, what is caching? I feel I'm doing a lot of talking. Alex is just standing there. That's right. Well, I'll make him pay later. So what are caches? There are caches everywhere, in all scales, in various different kinds of implementations. So obviously you have hardware caches inside your CPU, an L1 cache, an L2 cache, an L3 cache. Some of them are shared, some of them are exclusive to cores, some of them are write through, some of them are write behind. You also obviously have network caches, browser caches, disk caches. Your temporary internet files is effectively, if you have a Windows machine, is effectively a cache. You have squid proxy caches, your ISP may be using that you don't realize about. Caches everywhere. DNS system you can kind of think of as one massive exercise in global caching. Why? Why do we cache? Well, the basic principle here is if data is closer to you, it's better. If you can get things quicker, it's better. Slow is not good, fast is good. Let's make things fast, and things are fast when they're close. You don't want to go a long way to get something. I don't want to go too far to get to Starbucks. You don't want to go too far to get your data. And memory is cheap, really absurdly cheap. We recently tested on a 6 terabyte machine, by which I mean a machine that had 6 terabytes of RAM installed in a single chassis. It was a regular commodity, if you can call it that, x86 machine with 6 terabytes of RAM. It did have $250,000 worth of RAM in it, but if you told someone, even maybe 5 years ago,
640K would be enough.
Exactly.
Right?
And so memory is actually remarkably cheap and continuously getting cheaper. Yet your typical Java application doesn't actually use very much RAM. It uses, like my laptop has 8 gig of memory and it's 5 years old. And yet lots of Java heaps are significantly smaller than that. We're not utilizing our memory. So the question is, can I, by using caching, make things closer using all that memory? So the question is, how close? How much closer does memory get me? You probably cannot read that.
Who's ever seen those figures?
A bunch of people have seen this diagram. They recognize it even though they can't read the text.
Stolen off the internet shamelessly.
Shamelessly, because we're lazy. The black box represents 1 nanosecond. Does anyone know how long a nanosecond is? It's real quick, isn't it? But we don't really have a good feel for it unless somebody holds up pieces of string, like people talked about light nanoseconds. L1 cache reference, half a nanosecond. Ooh, that sounds short. A branch mispredict, 5 nanoseconds. Ooh, that sounds bad. That's a little longer than a half. This is all cool. The blue thing is equal to the black thing, and the blue, no, this doesn't make any sense. Right, human scales. This makes sense. Cool. If we take that half a nanosecond and if we take half a second and say that's an L1 cache reference, so that's pulling from the closest cache you will ever experience, assuming we don't count registers in the CPU as caches, although you could call them that. And we call that half a second. That's a heartbeat. So an L2 cache reference is when your little L1 cache misses. It's 7 seconds. A little bit longer, not the end of the world. A main memory reference is almost 2 minutes. That's a sizable length of time. I don't want to wait 2 minutes for some things. Sending 2 kilobytes over a 1 gig per second network. Now, this is a good thing to think about. If you use Memcache, you might be sending stuff over a 1 gig per second network every time you request it if you're using a thin client. Depending on the programming language you're using, you could well be using a thin client. 5.5 hours of time compared to the half second. That's an age. That's forever. Like, that's the amount of time I waste looking at Reddit every day. Don't tell my manager. Reading from memory sequentially, 2.9 days. So reading significant amount of memory takes a long time. And L1 cache reference is slow, but reading megabyte from memory, a long time. Now we get to the disks. SSDs, 11.5 days. That sounds slow. That really does sound really, really slow. Look at the time for reading from a spinning disk. It's 8 months. That's almost a baby. And you've got microservices and you deploy 9 of them and then you do it in a month. No, I'm lying. And obviously doing anything on the internet takes forever. Average time to a bachelor's degree.
I think that one thing that's really interesting to take away from those figures, like the scale to the side, right, is that if you look at this, you realize that actually going to the main memory of the server that sits below you in the same rack is going to be faster than going to your commodity hard drive. And that, I think, is something that's very interesting and explains why you want to make use of this memory that we have today at our fingertips for us to use. It is really a powerful concept.
Cool. We're moving on.
Let's move on.
So, as we said, cache is this thing. It's a data structure that holds a temporary copy of data. It's trading memory usage to reduce latency. So what we're going to do is we're going to take all this RAM we've got and going to whack as much data into it as we can. And rather than going over the network to read from the database and possibly the database pulling from disk, we're going to satisfy that read by reading from memory. So what are we going to read? Well, we're looking for things that are, there's two things that make us want to cache, right? We're looking for things that are reused, because that's multiple hits. That's multiplying the latency up many times. And that's not good. The other thing you want to worry about is, what is the cost of retrieving that? Now, fundamentally, I work for a big company, so this is the way I think. Fundamentally, it's dollars, it's money, it's euros, it's pounds, it's whatever you're thinking. Fundamentally, you want to save money. Now, money might be customers leaving because it took too long to get the web response back, and therefore they said, screw it, you took half a second to render this page, I'm gone. You've lost the customer, it's a conversion gone. It could be, every time I make a request to this external web service, they charge me. It could be, every byte that I transfer over this public interface, AWS charges me. There are many ways, but fundamentally, when we're talking about expense, we really are eventually talking about money, either in some kind of proxy, time, or data, or whatever. But it's important that you think about what's worth caching, because fundamentally it boils down to what do you value. We're shallow people, so we value money. So we know what caching is. We know that it's good, and we know we want to do lots of it. For a long, long time, if you wanted to cache, you thought I was going to tell a joke then. I will tell a joke later, don't worry. Okay. For a long, long time, we thought that you want to use a cache, right? You go buy cache, or you go and use a JCS, or you go talk to, you can use Redis as a cache, you can use Couchbase as a cache, you can use Gigaspace as grid gain. There's bunches of different caching providers. Some of them are little in-memory caches. You can use Guava as a cache. Some of them are little noddy in-memory caches. Some of them are great big enterprise massive deployment caches. Some of them store 5 meg. Some of them store 5 terabytes. But for the longest time, you picked one, you coded to it, and that was it. And somebody said that was bad. And said, no, we should have a standard for caching, so that a customer who's doing caching, particularly in Java, because Java is what we care about, even if we're Spring, said, no, we should be able to program to a standardized API, and then we should be able to plug in whatever implementation we want, so we can pick and choose and find the best one, or the one that suits our needs best. And so they said, we should write a standard. Then they started. And then a long, long time later, they finished. So what is JSR 107? JSR 107 is a Java platform specification. It's gone through the JSR process. What is the JCP process? It's this driven standard. The JSR 107 says it is it's an API and semantics for, the emphasis is ours,
it is.
temporary in-memory caching of Java objects, including object creation, shared access, spooling, invalidation, and consistency across JVMs. Try and not look at the bit at the end. It's not very good at doing that, in my opinion. Concentrate on temporary in-memory caching. That's really what 107's focus is when you start looking at it rationally. So yes, it was finally released on the 18th of March 2014. After, say, for example, I know JSR 347 and 350 and all sorts, even though they are numbered sequentially. So you can tell, it was out for a long time, but we finally got it done. And it's pretty good, reasonably happy. It works, it standardizes caching. So it comes with a standardized API, obviously, a TCK, so if you write a nice implementation, you can test it. Make sure it actually does what it's supposed to do. It comes with a reference implementation. Please, please, for the love of whatever deity you worship, do not use the reference implementation ever. Ever, ever, ever. There is no reason why you would ever need to use it.
That's not true. If you're single-threaded, only care about yourself, and you don't care about being fast, then you can use it.
Cool, yes. If you want a cache that is single-threaded and slow, you can use it.
Yeah.
Cool. Don't use it.
How many people want that cache? All
Right, that guy in the back, leave. Sorry, he works with us.
Well,
It's
no
fine.
longer.
Not anymore, he doesn't, no. Don't use the reference implementation. The expert group and the spec leads, JS 107 is a bit weird. The reference implementation was written to prove that you could write something to the API. It wasn't written to be used or to prove that it could do anything more than that. So it's merely a proof of concept. So it's distinctly not designed for use. What is in 107? The API, the bit that you care about, because you probably don't care about the TCK. So there are cache managers. Anyone that's used cache, that will sound familiar. Cache managers, they manage the caches. It's just a collection, a grouping. You can obviously naturally aggregate. You might have a cache manager for all your Hibernate caches. You might have a cache manager for all the Spring caches within a given service or unit of your application. You can choose to break this down however you like. Whatever's logical for you. It handles expiry. So that means TTIs, time to idle, TTL, time to live. You can, with 107, do more fancy things. You can do more fancy forms of expiry. You can inject your own policies. I would encourage you to think about staying with TTI and TTL unless you really know you need something different. Integration.
That's the whole cache. That's a module that provides everything around cache loading and cache
I don't think
writers.
Right behind, well, not right behind, right
through.
through or writers. So it basically allows you, it's methods to allow the cache to directly integrate with other parts of your application besides the thing that's calling the cache methods. We will talk about right behind and right through a little bit later. Cache entry listeners. So this is basically listening to events as they happen on the cache. You do a put, the cache will fire a put event on all the listeners. I wouldn't encourage your use for them, really. You want to think twice about what you're doing with it. It's fine for doing things like logging and that kind of thing. You might be able to drive a replication scheme with them, but you're probably going to find yourself pretty sensitive to the details of what the implementation is doing there. Entry processors, they allow you to atomically modify a value in a cache. That's all I'm going to say. I can't talk too much about entry processors, otherwise I get myself in trouble, because I don't like them, and I don't think they should be there. And I made that clear before. Sorry. Yes, caching annotations. So this will sound familiar. You go, yes, annotations, that sounds really friendly and nice, and I know what annotations are. I want to use them all the time. This is how you guys consume stuff. You're going to see some of this later on. The one thing I would say is you guys have a nice set of caching annotations.
Yeah. So how many people use the Spring caching annotations already? How many people use the JSL 107 annotations? All right. I think you kept your hand up for both of them, right? Yeah. So any preference? Which one you like better? The 107 ones, the Spring ones? Okay.
We're looking at the guy behind you. Sorry.
I think the Spring ones are really awesome. All right, cool.
And the thing is, if you weren't using Spring and you wanted cache annotations, use the 107 ones. But you guys are Spring. You are invested in Spring. You're not adding a dependency. Take your Spring annotations and run, because they're really nice. There's some weird things that I don't like about them, but on the whole, they're cool. And you get spell, or however you guys say that. I don't know. I'm not a Spring guy. The Spring expression language, it's nice. We don't have that.
We'll demo that.
I'm going to show you my really ham-fisted attempts to use that later. You get a small amount of management. So by default, 107, you have to, you can enable statistics, you can enable management, and what will then happen is the provider has to register a JMX bean at a known location. You can go and then get that bean and go, oh, look at what this cache is doing, which means you get some things like hit rates and miss rates and ratios and that kind of thing. So you can just basically check that the thing's actually doing something.
And that's something that, again, certainly Spring Boot exposes for you automatically with all the fancy stuff that you can include, so that you can very easily see how your cache is performing in your application automatically, sort of for free. There was a demo in the slot prior to this one, and it exposes all of that. It's nice because, again, whatever provider you're using, right, it's a standard way for exposing the stats of your cache and whatnot, so you get insights on how this cache helps your application. So very useful stuff.
So this last bullet point is not good. One of the key things you don't get with 107 is you don't get capacity control. And for anyone who works in a Java environment, when you can't control how much memory you're using, bad things tend to happen. It tends to sort of umi because it gets out of memory. Or, I don't know, if it was a disk cache, you would run out of disk. Running out of things isn't good. And so, to my mind, it is a shame that 107 can't do this. And it does mean that it's very hard, well, you'll see it's very hard to use a JSR 107 cache without resorting to some implementation-specific coding. The good thing is that you can confine that to config time. You can confine it to when you create the cache. When you are runtime interacting with the cache, which is the kind of stuff that where you're doing your annotations, or if you're calling the cache directly inside of your application, your business logic, there you can just deal with 107. It just means there's this kind of little wart sitting off on the side where there's a little bit of implementation-specific stuff, but it's kind of constrained. It's not ideal, but it's not the end of the world. So who implements it? So there's these 5. These are the these are the ones that are officially recognized. Oracle's coherence. It costs you lots of dollars, lots and lots and lots and lots and lots and lots of dollars, unless you're already giving Oracle lots and lots and lots and lots of dollars, in which case it's free.
Because you have so many dollars.
Because they've already got all your dollars, so you've got no more to give. Sorry, that was, yeah. Please don't sue me, Oracle. I didn't mean any of that. Terracotta ZH Cache, it is open source, and it's dollars. So if you want simple stuff, it's open source. If you want support, fancy stuff, it's some dollars. It's not as many dollars, though. Trust me. Hazelcast, it's open source. You want simple stuff, it's open source. Take it, use it, support it yourself. You want fancy stuff, it's dollars, but not Oracle dollars. JBoss is in Finispan. You want Infinispan? It's open source. JBoss, Red Hat, great, wonderful. Doesn't do everything though, but it's cool. We like Infinispan.
We like everyone.
We like everybody for the purposes of this talk, except Oracle. And Apache Ignite, which is relatively new to me, at least. Apache JCS and Gemfire, as we understand it, are working. They're not officially there yet. You can see this list if you go to the 107 page on the GCP.
Effectively, the list, the 5 first that you see there, actually officially passed the TCK. Right? They're proving that they play by the spec. The other ones are still working on it.
But they'll get there.
Probably so.
Good. One important caveat for me to mention here. JSR 107 is store by value by default. I'm trying to remember how the transitions work here. Cool, yes, it does that, good. JSR 107 gives you 2 choices. You can, it's a Boolean, store by value. Do you want store by value or don't you? And so it interprets that as you want store by value or you want store by reference. So store by value would be saying the cache must store this value, which means it must, at the point when you give it to it, it must copy the value and stick it in the cache. That means if I subsequently go and tweak my value, The cache doesn't see the change. It also means the converse. When you get from the cache, it must also copy it, so that you see the value that's in the cache, but if you modify it, it doesn't modify whatever's in the cache. You probably do not want that behavior. Well, you probably want the behavior, but you don't want the overhead, because every time you push the value from your world to the cache's world or vice versa, there's the danger of it having to do a defensive copy to make sure that you're not messing with it. You probably don't want that. Store by reference. So store by reference, you might think you want. Store by reference says, well, the cache is not storing the value, it's storing a reference to the value, which means if I touch the value and change it, then the value in the cache is touched and changed because it only refers to the value. The problem is, store by reference is something that's really hard to give if I have to, I don't know, save it in a cluster or save it on the disk. In order to technically maintain referential integrity, I have to jump through crazy hoops. What do you want? You want store. I don't give a fuck what you do with it. Just store the damn thing. I don't want by value. I don't want by reference. I want whatever you think is fastest. Which means if it's in heap, store the reference. If it's in off heap, store the value and marshal and unmarshal by whatever method you do it. If it's over the network, yeah, push the value. I'll copy it when I want to copy it, and I won't when I won't, and I assume you aren't going to do evil things that will break stuff. So as long as you're not doing evil stuff, fine. Most of the implementations out there, I would suggest you either look at whether you can configure them in their native configs to do the right thing, or configure store by reference, because most of them are probably going to sort of fudge things a little bit and assume that store by reference, they don't have to maintain referential integrity when moving through things like disks and clusters and off heap and that kind of thing, outside the heap effectively. So that's just a short sort of caveat. For example, EHCache, by default in 3, if you ask for store by value through a 107 provider, we are going to defensively serialize and deserialize this stupid thing every time. So it's really annoying. At this point, I'm going to hand off because, as you will see later, my IDE usage is agonizing.
It's different. He's the guy using NetBeans.
Which is why it's agonizing, obviously. It's not me, it's NetBeans.
Right. That's what I was saying. Excuse me. All right. So I'm going to show you how many people know the pet clinic.
How many people can read that?
Nobody can read that. It's okay. All right. So pet clinic is this thing it's a demo app. It's the stuff that I have there is effectively cloned directly from GitHub, and actually this. Oh man, I'm gonna cough all the time. This uses All right, here we go. This uses caching directly out of the box. So it demos like a bunch of aspects of things that you can do with Spring, and that's a Spring app, not a Spring Boot app. Okay? So it actually, by default, somewhere, let me find this, uses EHCache. I'm sure it does. I don't know EHCache and EHCache. All right. So it uses Hibernate to, amongst other things, but we're going to focus on the Hibernate stuff, and it uses EHCache to do all its caching work. The way that, I guess you guys know all that actually way better than I will ever know, which is how to configure your application use caching, right? So in this case, you use XML to configure stuff. I didn't look into the Groovy things, and apparently this app is really as it is currently on GitHub, or was 3 days ago. So it tells that we want to use the caching annotations, that is that piece of work here, so that we can search for cacheable and do like all the annotation-driven stuff to cache things. It configures as a bean here to be our EHCache cache manager. And then it uses some bean factory to create this, pointing to some EHCache specific config. So the add cacheable app, where is it? Vets. pet, no, is it clinic service? Clinic service, simple. There we go. So this is, it's currently being used in a couple of places. So it's being used in this thing here that gets like all the vets. Should I run the application? You guys, so, because I didn't see like all hands go up when I said, do you know about the pet clinic? So kind of amazed, but okay, so maybe I can run this quickly. So that should be running, and if I only remember on what port it's running, maybe I bookmarked this. Yes, I did. So this runs on my computer, right? So it's a pet clinic. Yeah, isn't that cute? All right. So, and when I go click like the veterinarian link here, over here, right? I find like all the vets and including their specialties that exist in the system. So what this calls, in order to present this awesome information here, it calls into this guy here. That's my service. It's marked as @cacheable. So now actually if I refresh this, it's gonna hit the cache every time. Which calls into the repository that comes in a couple of flavors. So that's the JPA one that effectively creates a query, goes to, so that is our entity manager, which is the JPA spec, and in the back uses Hibernate as provider, and go fetches all the vets, does left join in order to get all the specialties, order them, and sends the result back. Okay? So there is something that's kind of weird in this example. I never really understood why it was that way, but it's actually being cached twice, which is something slightly interesting. It gets so easy to cache stuff with Spring that you can easily put a little bit of annotation here, a little bit of an annotation there, and all over the place, and it all works. And as you could see, like I run this, and currently it all works. There is a slight problem with all this though, because since we're caching so much in this case, right? So this method calls into our repository that is cached, puts the data inside a cache called vets here, okay? The result gets returned, and that gets re-put inside a cache called vets under the same key and everything. So I'm actually maintaining my cache. Like I create the entry in the cache the first time, I overwrite it right away, and then everybody can use it. So I found this interesting that that's the case inside the demo app for Spring. It gets so easy that sometimes you forget what you do, but at runtime, you're actually paying the cost of this, right? You're actually asking the cache to be overly maintained. You're actually caching the same thing twice. So if you would be using a 107 cache and using the store by value, you're actually also asking the cache to defensively copy the data twice. Okay, so in this particular case, it's not so much of a problem because what we're doing here is it really is a one-time caching up, right? It's now, we don't know exactly how this is TTI and TTL'd, but the data is going to remain in there for probably a long time, and that's the one single thing we're caching in this case for the entire app, right? So if you look at this, I can come back here, it's always going to be the same list of people. So it's not so much of a problem. But if we would to cache like way more things than only that, you would be like paying a whole lot of overhead into maintaining your caches. So I thought that's something interesting. So anyways, that's what we get. Actually, I think if we, oops, sorry, wrong thing. I think we can actually prove that it works essentially, right? So as you can see, this is the query that Hibernate issued the first time. And after that, you can see that it's not issuing any query anymore, right? Because we're reading from the cache, not hitting the system of record anymore. So that's good. So that's awesome. Now let's say we're using cache, but we're not happy with cache, like that would ever be possible. But whatever. Let's say we're not happy with cache, and what we want to do is actually we want to use just 107 so that I can easily drop another provider on the class path, because that's theoretically all they would take, right? So what 107 provides is this called, what is it called again, the caching provider thing or whatnot. So and Spring does all that for you in the back, so you don't need to worry about that. But effectively what it will do is it will look up on the class path to figure out, all right, is there anything that can actually provide caching for me? So what, as you saw, why is it not here? Should be tools config, right. So we need to change that. So there are a couple of things that we need to change. We need to change our POM file to say that we don't care about cache anymore. Well, actually, we will care about cache in a second. So we're going to do a couple of things. We're going to change this, and we're going to use cache still as the provider, but we're going to use cache 3.0, which is the new stuff. Awesome. I'm using a snapshot because I like living dangerously.
I like the non-SourceForge group, buddy. That's good.
Oh, yeah.
SourceForge is
Yeah, so
SourceForge is now evil, for those of you that didn't know.
So, yeah, yeah, well, we changed all that. So now everything is inside, as of 3.0, everything is inside org.cache if you're using that already. So that's, what is it? Cache, right?
Cache API.
Oh, cache API, right. Cache API, and that comes into what?
108.
100. All right, so I'm changing that. I'm telling TJ to refresh so that it knows. All right, so that's done. So what I need to do now is change this guy here to use a JCache manager instead. That's done. It's going to use some, I'm going to call it CM just for the sake of it. And now I need to create some cache manager for this. All right, so that's done. And now there's one thing that I need to change is the config place, right? So, so the way that you configure a JCache is with actually two things, even though I'm only going to configure one. Oh, am I wrong? Oh yes, sorry, that's not correct. I knew that doing live coding was dangerous. Chris told me it's a bad idea, don't do this, you'll screw up. I said no.
I'm going to do it later, so.
All right, it's this guy I'm looking for. All right, and what we're going to say is, sorry, I'm going to actually provide a cache manager URI, okay? So what this means, a URI in JSON 107, and if I say something wrong, the expert group member here will correct me. It actually is a way to, well, to identify uniquely a cache manager. What sits at the other end of this URI is, we're not quite sure.
Well, it's up to the implementation's business.
It's up to the
You
implementation.
can do sane things or you can do insane things, and the spec doesn't care.
Indeed.
We do sane things, right?
I like to believe we do.
Cool.
I realize, okay, I'm going to cheat a bit. I think I'm going to change to another branch in order to get to the, let's kill this, get branch again. Check -f. What do I need to?
You need to tell
No.
it which branch.
No, it's okay.
Oh, you already need to check out
Yeah, I wanted to
specific
do
cache.
that, and then I'm going to go to JSON 107. Okay, I'm cheating a bit. It's going to be the same code, as you'll see in a bit. So we're back to this. The one thing that I cheated is I didn't want to have to redo this guy here. So that's that. In the case of cache, we're going to point to an XML file that actually configures the cache that we talked about, the vets cache, and we're gonna like give it a size. So we're gonna constrain it in the resource they can use to a size of 2,000 entries in this case, only on heap. We'll talk about the other resources type that we support later down the path. But effectively what we're doing here is we're constraining the size, and that is obviously not just JSON 107, right? This is pure cache config, so if you use Hazelcast, you'll have to configure it their ways, and so forth, right? So that's what we do here. So in order to constrain the cache.
Note that anyone who's familiar with the cache, this is the cache 3 config.
Right.
And I'm really annoying the AD guy now. Sorry. This is cache 3 config. If you don't like this, or you think this is ugly, please tell us, because it can change. Cool.
All right, so that's all we do. So effectively what we've done, right, just to quickly recap this, we simply changed the, we added the jcache API on our class path. We added the hcache3 on the class path. Yes, we had to do one thing that's hcache3 specific, that's the config, but that is just the way the spec is. And then well, that's it, actually. There's probably more that I did here, like changing to the 107 ones. No, I didn't. Awesome. So, all right. So normally, if I run this now, pet controller, no, vets controller test. This may be a better one to run. So if I run this test here, I think this creates a little bit more noise, a little less noise. Hopefully this works now. Otherwise I look like an idiot, but it's okay. All right. Actually, yeah, there isn't really anything that shows. You will just have to take my word for it. This is all hcache3 logging. So we had nothing, there is nothing in the app that is other than the config. Again, that's hcache3 specific, but now we can use hcache3. And if we're not happy with it, which again would never happen, you can drop another provider in there, configure it its way, and you're effectively totally decoupled from what happens in the back, right? There is technically, other than the config to where to source the URI for the cache, there is no code changes to be done. All right. So there is another thing that looking at this application I found very interesting, and that is this annotation here, which internally uses caches the result of whatever this query returns. So who uses JPA, Hibernate, whichever ORM that you want? Does anybody see anything that is slightly alarming with what is going on in this cache?
If you read my cache twice, if you enable the second level cache as well.
Oh yeah, there is that too. So in this case, we would even cache 3 times because, right. But there is, so yes, that's true, and I'm gonna get back to that in a bit. But there is something that is very wrong with what's going on here, except if you store by value, actually. What this, yeah? Sorry?
He said it's running a SQL query directly. Sorry.
Yeah, well, actually, yeah. Okay, well, that can be discussed. I can, no, the gotcha here is anybody knows about the JPA entity lifecycle contract? All right, so this is where everything falls apart. So effectively what we're doing in this code here, we're caching what's called like attached JPA entities, right, that are currently managed by the session, i.e., well, this session is how Hibernate calls it, but effectively that's the entity manager that's here. Because I don't think I'm going to demo the race, because I think otherwise we'll not cover everything we have to cover. But effectively what you're putting in the cache are entities that are still attached, i.e. managed by a session, right? As soon as you put them in the cache, certainly if you store by reference, you're being okay with those references being shared among multiple threads. The problem is an entity manager or an Hibernate session is never to be shared across threads. This class is not even thread safe the way that's implemented. Furthermore, well, the fact that it's still attached, it's actually that your vet here, actually this class here, as you can see, has a set of specialties attached to it, okay? So these are all JPA entities. In this case, it says that it's managed eagerly and so forth, but let's say this was lazy, okay? Now, if somebody like navigates the graph and goes to a specialties, what Hibernate will do is it will go back to the database and load the rest of the information, right? It will do that either in the isolation of the current transaction, or if the transaction is let's say, ended one way or another, but the session is still open, it's going to load stuff. For instance, who knows about the open, what is it called again? Open session in view filter that, right? So, because you had those, you know, like, oh, the session's closed, I can't load the data, right? Now the problem is, if multiple threads try to do this at the same time, the best way to put it is undefined behavior will happen, right? I hope for the best.
Still the girlfriend.
More so, if the transaction is still running and anything touches, like mutates any of these entities, right? As soon as the transaction, at the latest point in time when the transaction commits, what Hibernate will do is say, all right, so you changed those entities, I'm going to flush that state back to the underlying system of record. Right? Again, same thing, if multiple threads change at the same time. In the best case, you wrote your domain model in a thread-safe manner so that all threads actually see the proper state, even though they share the same entry. But again, the same problem exists, is that actually, has anybody ever written multi-threaded JDBC one transaction access? Okay, was that fun? No.
He shook his head, for the record.
Right? Yeah, he shook his head. It's a nightmare. In the best case, you're working with a JDBC connection that's actually itself thread safe, of which the chances are really low. It's a nightmare. You don't want to have to do that ever. And that's if you do it manually, so hats off. You were brave. The Hibernate guys never went down this route. A session is never to be shared. But as soon as you do what we're doing here, right, you actually effectively sharing managed entities across threads, i.e. sharing the transaction across threads, except if it's a JTA one, because that one's actually bound to your thread. And you're certainly sharing the JDBC connection to your database across multiple threads. It's a recipe for disaster. Obviously, when you run this like I just did on a single machine, and in this particular case, actually turns out this is not all too bad, because it turns out that this is marked as being transactional read-only, and the whole model is loaded into memory because the association is marked eager, and there is actually a left join to actually populate everything and blah, blah, blah. So you're good to go and you're sort of saved and it happens to work, but I would actually say this is an anti-pattern and you never really want to do this. So I had a quick example that actually uses some listeners to actually show the race. No, I could actually quickly, yeah, I'm going to switch to a branch. That's going to work, and then I can.
I mean, the long story short here is,
Yeah.
you might not think you're doing multi-threaded, it's going to switch the camera now, sorry. You might not think you're doing multi-threaded programming, but caching is multi-threaded. Unless it's something like a Hibernate session cache, oh my god, I said another Hibernate concept, which is inherently single-threaded. JSR 107 caches are going to be multi-threaded. Whatever you stick in that thing, you started doing multi-threaded programming. Congratulations. Now, make sure you do it right, please, because you can easily tie yourself in knots. So best thing to do, stick things in caches that are immutable. It's the whole, concurrency is hard unless there's no state changes. If everything's immutable, then you're fine. So try and stick immutable things in your cache. And please, 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 if you're going to put mutable things in your cache, at least only put in mutable values.
Right, not keys. That's
Not keys. That's really, really bad. That's you have weird things happening. Like we had somebody who couldn't remove something from their cache.
Yeah.
Because they'd mutated the key and its hash code changed.
That's a hypothetical use case. Nobody in real life would ever do that.
Nobody would be stupid enough to do that. And then
So the code that's there, what it does is kind of simulate sort of multi-threaded access to this data structure so those managed beans that we have there, right? So what we do, hopefully this works, because obviously it's racy code, so it doesn't always work. So what this does is actually, I'm slightly cheating in this test. What I do is I register a listener that's asynchronous with the with the cache manager, so that when the populating thread would actually put the data in the cache, this other thread would come around and actually do stuff with it. So what I do with it is actually I get the stuff out of my cache, and what I do for every vet that's in there, right, I'm gonna change its first name to, because I'm totally not egocentric, to my own first name, which is way better. And if I actually run this, because we actually have the SQL output enabled, what we should see is that the output is totally non-deterministic. And well, thinking hard, that's to simulate the first access to the slow database underneath of it. So as you can see, there are 6 vets. They're all being renamed to being Alex instead. And obviously it works. God damn it. All right, let's rerun it. There's this thing, supposedly you have to kill kittens so that your demos work in presentations, but who wants to kill kittens for real? All right, so here we go, that worked. So as you can see, the red output, right? So I created this key under which I store like all the vets, and all the vets are those managed entities. And I renamed all of them so that their first name is actually Alex, right? But the transaction demarcation is using the @transactional. So I removed the read-only that we had there. So the thread that actually populates the stuff continues, right? So it returns the set, blah, 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 to the user and moves on. Now, though, if you check, you'll see that we did the selects and whatnot. But in terms of updates, we only have 2 in there. So we did update the first name of 2 of our vets in the system of records. But if I go check at the output somewhere here, where is it? I won't be able to find it. All of them are first name Alex. And what we have there is the stuff that's in the cache now. Right, so first name Alex, ID 6. So they're all first name Alex, right? Because what happened is that one thread was racing against committing the transaction, while the other one was renaming stuff. So when the first thread committed the transactions, it saw that 2 vets were renamed. So those 2 were flushed to the database. And then it moved on. But the other thread kept on renaming stuff, had reference to stuff that was in the cache. So long story short, what I have now is a cache that says foo, and I got a database that says bar. So the state is out of sync. Very bad. Never ever do that. Right, so what JPA does, if you really want to do this, what JPA does, it gives you like not any POJO back. What it gives you is the POJO that has a life cycle. It's either transient, persistent, detached, or removed. This is, if my memory serves, what the spec says. When it's transient, it means that you just mute it. It's not attached to a session. It's fair. When it's detached, it's not attached to a session either, so do whatever you want with it. And when it's removed, it's been marked for deletion, right? The delete, again, happening when at the latest point when the commit happens, but it could be earlier than that. As soon as it's attached, it means it's non-thread safe. However much care you put into designing your data model. And again, as I said, the session will flush updates to the system of records at transaction commit at the latest point, but it could be earlier than that. An example is if you issue a search query to the database, it doesn't know how the search query is being affected by the transient state that's still like the pending mutations. So it needs to do the updates to the system of records first, and then do the search query. Long story short, many open doors for a bunch of race conditions. So what you want to do is indeed use the Hibernate second level cache. What Hibernate second level cache does, it doesn't store like your vets or your pets or your customers or whatnot. It stores dehydrated entities. The simplest way to think about the dehydrated entity is it's each column value, well, name value pairs like in a map, right? Have, I don't know, first name Alex, blah, blah, blah. And then when it hits the second level cache, what it will do is it will populate the domain model instance with that raw data. And all of that is maintained through Hibernate or JPA, right? A bunch of other implementers come with different solutions around that. I know Hibernate best because I've been working on that a lot. Anybody using anything else than Hibernate as an ORM? All right, handful. 2 people actually. Okay, sorry. Maybe I know stuff about the one you're using, maybe I don't, but yeah. The Hibernate stuff I really know well. So the session itself acts as what is called the first level cache, right? So if you do get customer ID 1 twice in a row, the first object will be equal, the same reference to that object. The second level cache, though, if thread 1 does it, and well, the session 1 does it and session 2 does it, right? they will get different objects back, even though they both hit the raw data in the cache, what I call the dehydrated entity. Hibernate comes with 4 caching strategies that you probably want to know about. Those caching strategies are either applied directly to entities or associations. So read-only, as the name says, it's read-only. It's data like, I don't know, like the 50 states, right? Not only are they immutable, but there are, as far as we know, no more states coming up. Read-write gives you, well, you can change the data. It offers a small window for stale data to be possibly observed after transaction commits. Non-strict rewrite is faster, but offers, well, it's less costly to maintain, but offers a bigger window. And then there is transactional, which offers no window whatsoever to see like outdated data, but requires you to run an XA environment. How many people run a JTA XA environment currently? Again, yeah, 2 people. And the very brave guy that was doing it. Nah, I'm not sure how I feel, but you're very brave. But generally, XA comes at a cost again, right? It's two-phase commit, it's way more chatty, blah, blah, blah. It sort of works against caching.
Use it if you need it, don't if you don't.
Well, and certainly with the cache, but we'll discuss this further down the path as well. So Hibernate also comes with the query cache. Query caches query results, obviously, and it's also responsible for invalidating the cache query results. So the way that this works is, it's not entirely true. I'm going to say, like, it holds a timestamp of the last mutative operation to a table, an entire table, okay? So if at time t I cache a result, then at t plus 10, some other thread comes around and adds or mutates any entry in this table. If somebody else reruns the same query, it's gonna go check, all right, so this cache result comes from t, but I can so this cache query had its table A and B, and I can see that table A was modified at t plus 10. So this result is invalid. I drop it on the floor and I rerun the query. Sadly enough, this timestamp cache that it uses to maintain all this data, the freshness of your result, can actually become the bottleneck if the query results that you cache are being sourced from tables that are mutated a lot. So caching is not always awesome because maintaining your cache is like the double caching example that we had previously.
Cache invalidation is
right.
hard.
Cache invalidation is really hard, and so make sure you really understand the use cases. All right, so that leads us to hcache 3, which we also call like JSL 107 on steroid, because, well, that's what I call it. Because it just
It's what we think 107 should have been if it was just our standard.
Yeah,
It's not our standard.
yeah, it wouldn't be a standard in that case because we only deal with our problems and we leave other cache vendors deal with their own problems. So one concept that we add in the hcache 3 that's not covered by JSL 107 is what we call write behind. So what write behind, generally you use a cache to scale out your reads, but what write behind lets you do is actually scale out your writes. And it does that in a couple of ways. So first, so when you register through the 107 API or through hcache API, you can register what's called a cache writer, so that when you do a put to your cache, the cache will also write whatever you've put there to the underlying system of records to some glue code that you pass to it. And right behind what we'll let you do is control how, like in what size of batches you want data to be written out to the underlying system of record. And the write will not happen in line, but will happen at a later point in time through a thread, a background thread that runs. So you can all of a sudden have customers be written in batches of 10. You can make sure that batches never become any older than 5 seconds. So that if I don't see any 10 updates to customers in 5 seconds, I still write the batch out so that I don't lose my data. I can also make sure that writes don't happen any faster than like at the given rate, let's say once per second, right? As Chris said earlier, maybe you have to pay the bytes that you send over the wires to a system of record, or say you use mainframe and you actually build by the amounts of writes that you do. You make sure that you don't hit the system too hard. You can control the concurrency of queues and obviously then threads that will write the data out to the system. And it also lets you do coalescing. So what coalescing is if, let's say, if in my batch of 10 writes, there are 3 writes for the same customer, instead of writing V1, V2, and V3, it's going to skip the first 2 versions and only write the latest version to a system of record. Right? This can be something very powerful for something, let's say, like a view counter, randomly, totally randomly, right? So if you have a page view counter, right, you don't care about that the system of record like writes every single view to it. It's okay if every second it writes the newest value based on the views that happened within the last second. In order to do all that, the way the write behind works, it actually queues writes up onto queues. You need to be careful depending on the topology of your cache. This queue may not be persistent. It could also mean that in case of a crash, the last views of the last seconds are actually lost. And it also, for persistent ones, for instance, if you use Terracotta in order to cluster your cache, we actually provide what's called like at least once guarantee. It means that a write will happen at least once, but could also happen twice. In the face of failure, it could be that we couldn't, so that's the two-phase commit problem, right? We can only really remove something of the queue once we know it's been written, right? But if the system crashes right after your transaction commits to the system of record, well, the system of record was updated, but we didn't have time to drop the thing off the queue necessarily. Again, only important if you really deal into distributed systems, with distributed systems. Also, we made it much more simpler in EHCache 3. If you've been playing with that in EHCache 2, you had to be very careful that data still in the queue wasn't being evicted from your cache. In EHCache 3, what we do is for as long as it's in the queue, it will always be visible to reader threads. So less ways for you to shoot yourself in the foot. Another thing that we have in EHCache is what we call our off-heap storage. So off-heap storage is memory that's allocated to the JVM process, but it is not being matched by the GC. You can use the biggest stuff that we've been running until now is the 6 terabyte machine. The 6 terabyte machine. So it's a single process that can store 6 terabyte of data in memory, but you don't incur any GC pause of running, of having a GC walking through 6 terabytes of heap. There's been a whole lot of discussion around SunDisk unsafe. And EHCache has been mentioned multiple times as using unsafe, and yes, it's true. But EHCache doesn't use unsafe for its off-heap implementation. Off-heap implementation is all open source. You can go see it on GitHub, so you can verify for yourself if you don't take my word for it. We do use unsafe in a couple of places, but it's not even our first choice. And in case we can't get to unsafe, we have fallback mechanisms. And this will also be true for EHCache 3. So if we can be very, very fast and very, very smart, we will be that. And if that means use unsafe, we'll do that. But we will never force anybody to, well, because there are a simple reason, right? Some VMs simply don't even have that, or with broken or different semantics and so forth.
It starts with Sun, not with
Yeah, it starts with Sun, as you can say, and C, and what's Sun, by the way? Yes. So all stuff is, our off-heap implementation was open source earlier this year. EHCache 3 totally makes use of that. It's available as its own library, so it exposes a couple of ways, other ways to use it in a cache if you want to. Again, all on GitHub. By default, it uses what we call like a lightweight Java serialization. We do a couple of tricks in order to make the footprint of the serialized data smaller, the memory footprint, that is. So that's a default thing. So if you want to store data off heap, we need your object graph to be serializable. But as of EHCache 3, if you want to plug in your own serialization mechanism, whether it being Cryo or Google Protocol Buffer, what have you, you can totally do that. We'll let you do that. That wasn't an option in EHCache 2, but it is now an option in EHCache v3. By default, our off-heap storage for the cache will use what's called a clock evictor. So a clock evictor is effectively an evictor that has a hand walking all over the entries that's inside your cache. When you touch an entry, I read it, we mark the thing as, we set a bit, and the clock hand actually walks and unsets the bit in parallel, right? When the clock hand needs to find an eviction candidate, it goes, unsets the bit all over the place until it finds the first entry that doesn't have the bit set already, and that becomes the victim for eviction. It is pretty close to
it's a fast LRU.
right.
Basically.
So I least recently used algorithm for eviction. When you use off-heap, though, the way that each cache works, it uses a tiered model to store data, so that kind of really actually the equivalent of what you have in CPUs, right? So the closest memory to you will be your heap, right? And you can say, okay, I want to use, like I did in the example prior to that, right? I said I want to have 2,000 elements on heap. Then I can say that I allocate 2 terabytes of memory to the off-heap, which means the off-heap is considered now suddenly my authority. So everything that goes into the cache goes to the authority. But when I access the cache, it folds data into the higher tiers, so they're closer to me. So this way, you should always have your hot set the closest to you, which leads back to what Chris said earlier about if you have a proper model and think about caching properly, I don't mutate stuff after the fact and so forth, what you care about is store effectively. Make sure that I can get to that data as quickly as possible when I need it, whether it's by value, by reference, I don't really care. I just want the thing to be stored as effectively as possible. So obviously it's all stackable, so that if you use clustering in the back through the Terracotta server array, you can have data sit on the Terracotta server. It can sit also off heap and in heap, depending on how hot it is, so that you don't necessarily pay a network round trip every time that you need to fetch something. In the case another system mutates the data that's in your local cache on your JVM, the Terracotta infrastructure will make sure to invalidate, tell that node that this entry is now stale and needs to either kick it or refresh it. All right, that leads us to another demo, and here comes the guy that uses epics.
I will try and make this fast and painless, and I'm going to cheat. Not using NetBeans. Well, I will use NetBeans. So I am not a Spring developer, which means it's pretty impressive that I managed to write a Spring Boot app. I didn't get it right first time.
I'm actually pretty impressed. I managed to write code altogether. Every time you just surprise me when you do that.
You've got the scrolling working backwards.
Yeah, just to confuse you.
Oh, God. Right, sorry. Weirdos. This is my Spring video application. It's a Spring Boot app, application runner. I don't know why I have to do this. If somebody knows Spring, why do I have to do that so the stupid thing terminates? Anyway, tell me afterwards. As you can see, I have an auto-wired video repository, and we'll look at that in a minute. You run the app. I save a new video, ID 69, my embarrassing viral video. You can't watch that video. It doesn't exist. This is a really, really mocked up demo. And then it gets seen 11 times. We watched it, we read the video from the repository, we watch the video, and we save it back to the repository because we've updated the view count. And like a good boy, my video class is immutable, because immutable is good. If this is bad Spring, don't tell me.
Sorry about that.
I really, really am sorry though. And then I sleep for 6 seconds because it was viral quickly and then nobody cared. And then I delete it because I realized it was embarrassing. I don't know why. I probably wouldn't do that. I have no shame. So let's have a look at the video repository. So videos are a component, and it saves into a map because I'm lazy. And it says we're saving video, and then we do some work, and we sleep. Okay, it's really canned. Look, I handle interrupt exceptions in a sane way. So this is the video repository. It does the obvious. You save, it does a put on the map. You read, it does a get on the map. You delete, it does a remove on the map. It's really, really kind of dumb. And so I want to cache this thing. So what do? Well, because I've cheated slightly, how long do we have? Yeah, we're going to cheat. Cool. Watch this. Cool. So I just added caching annotations and dependencies. This is way faster than it was in the keynote. Like, they should have done their demos like this. Look, it's magic. I was going to do this for real. I really was, but I think this is cooler in some ways. Sweet. So let's have a look. So Spring Video Application. Look, it's enabled caching. Cool. What did we do? Oh yes, we also modified the POM. Let's look at the POM. Notice I didn't also have to click a button to refresh things like you do in IntelliJ. It just goes, ooh, look, you changed things. I'll just change things.
All right.
That is the only IntelliJ dig in the entire talk, I swear.
Okay. You also use
so-
javax, but I won't get into that. Okay.
Cover Cache API, cache, milestone 2, latest release. Good. Have that. Cool. So we enabled caching, and we added some caching annotations in our video repository. So what are we doing? Well, first config the cache at the top. We're going to call the cache video cache. Nice name. Cool. Makes sense. Let's put the cache. Now, for reasons I do not understand, and maybe someone, Springy, could explain it to me afterwards, the cache put annotation in 107 puts to the cache. So in the sense that if you annotate a method in 107, this is one of the reasons you shouldn't mix them, because it gets very confusing. If the cache put annotation in 107, you call it and you specify a key generator and a value generator, and it puts that combination. So it sources the value from the parameters of the method, which means that you naturally annotate a method that's writing to your underlying system of record with the thing, and it will update the cache. What Spring does is the key is sourced from the parameter, and the value is sourced from the return. So it's like to me, that's a logical inversion. It's a bit weird. I'd love to, there's probably a good reason, but I don't know it. So I had to tweak this slightly and return a video, which looks a bit weird and arcane to me, but whatever. This is nice, I like this. So this is actually extracting the get ID from the video.
Which is really nice, because in the case of 107 though, what I would have to do is a save method that tells the ID, which would be say video.getID, then comma video the video that I want to save. But when you call this method, it feels like really awkward.
Yeah.
Why do I need to do this?
Yeah.
Well, just so to play the annotation.
Well, that's wrong.
So, yeah.
The rest of this is really nice and natural. The read is cacheable. The delete is a cache evict. It automatically picks up the ID and uses that as a key, and it all deletes, and it's great. This is sweet. It's a component, and everything works. So if I run this, oh shoot. Come on. Sweet. Cool. Oh, crap.
Cool.
Something went wrong. Shit.
The kitten.
Oh, crap. It can't find the cache video cache. Why can't it find the cache video? I know why it can't find the cache video cache. That was canned. That was an intentional failure.
Seen that?
That was cool. So by default, so EHCache2 and EHCache3 have differing behaviors here. EHCache2 by default, if you has a thing called a default cache configuration, basically, you create a cache, you ask for a cache that doesn't exist, and it can use a default configuration to bootstrap one. EHCache3 doesn't do that. You configure the cache, i.e. get cache and create cache do what they say. Get cache gets it if it exists, create cache creates it.
Which is also what 107 does, by the way. Right?
Yes. Well,
there is a create cache.
There is a create cache and there's a get cache.
And then there is a get.
So by the magic of magic, so we can make Spring create our cache for us, which is nice.
Spring Boot, I think.
Well, yes, Spring Boot. Oh, it's all Spring to me. So we accomplish that by doing this. Spring cache, cache names equals video cache. It basically says, please Spring Boot, or Spring Boot, Spring cache, please create my cache for me because I can't do it, because I'm ineffectual, I'm useless.
No, because it's not covered by the specs. It actually covers something that
Cool.
the spec doesn't
Yeah,
cover.
there you go. So now we can run it. Sweet. Oh, crap. Now what's wrong? Oh, shit. Yeah, it failed again. Hang on. What was it? Not serializable. Oh, crap. Okay, that was Cantu. What did I do wrong? Why does it need to be serializable? Why does it need to be serializable? Because it's by value. The cache is by value because I didn't tell it otherwise. So that has to implement, serializable. Sweet. Nope. And of course something went wrong and Spring Boot didn't terminate and I don't know why, whatever. How much time do I have? Oh, sweet, okay. Hey, look at that. So we offloaded all the read. You see it's not saying read ever. All the read is offloaded through the cache. But this is the problem that Alex talked about. It's writing every single view count. Every single one of these things is a write to my system of record. That's a DB write. And if I'm YouTube and I multiply that up by 1 million videos or whatever, that's not good. And so what can we do to fix that? Let's go real fast here. Oops, sorry. Let's kill that and say get next. Okay, that just did what I did before. Cool. So let's just skip to the end. Right, because I want to. Oh, I don't want that IDE. Thank you. Right, this IDE. Good IDE. So what does our repository look like now? Oh, look at that. That looks fancy. So this is a Jcache manager. This is Spring. This thing, whether I get hand of the weird scrolling, is a Jcache manager customizer. So it's a component. And when Spring sees this, it says, oh, you have a Jcache manager customizer. Let me hand you the javax.cache'ing cache manager. And I say, yes, please, I'll take that. I'm going to create the cache. So coincident with this, you'll see that we've deleted the Spring. I say, it's fine, I'm creating it now. But I'm going to create it with my own configuration. And obviously, this thing here is GSR 107 method. And it takes the GSR 107 configuration. And that thing's really limited. So 107 doesn't have write behind. But I can wrap an cache configuration as a 107, inject it through the 107 API, and then find it on the other side. Cool, sorry, I'm moving my mic around. So I create a new cache configuration builder. I add my writer configuration. The writer writes to the real video repository, not the fake one, which does system of record writes. And then I add a write behind configuration. I batch 10, this is what Alex talked about. I delay 2 files, so that's 2 seconds min delay, which means I will not write for 2 seconds. So I will wait for 2 seconds for a batch to appear, and I will wait at most 5. So if I wait for 5 and the batch isn't filled, I will write the batch anyway. And I enable the coalescing. And then I build the config, and then I inject it, and it creates the cache, and everything's great. The thing is, I've done some weird things to my methods here. The save method does nothing. The read method throws an assertion error, and the delete method does nothing. And that's because I don't need these anymore. This method will never get called. I will never throw this assertion error, and I'm not going to fake this. It will not get thrown, because the cache will intercept everything. If the cache hits, it returns. If the cache misses, it calls the loader, which returns, and it returns. Technically, I shouldn't do that. I should actually return something same, because obviously if the loader misses, then that's bad, but we'll pretend that didn't happen. The save doesn't need to do anything, because I'm handling the writing and the write behind, and the delete doesn't need to do anything. I'm handling the writing and the write behind. The real video repository looks like this. This is an cache 3 cache loader, cache writer. The reason I've used an cache 3 one and not a GSR 107 one here is that we combine loader and writer into one interface because we think semantically that makes sense. We think it's weird having the idea of a writer without a loader or a loader without a writer, and we'd rather encourage you to have them as one. 107 splits them, and you can have one without the other, and you can have them talking to different things, and that just seems weird to me. Obviously, you can make this thing talk to 2 different system of records, but you don't have to. So this looks very similar to before. Save, read, delete, and work. Not really. And then these are the methods from my data writer. So load all. I'm not going to use this one, so I just throw it in support operation. This obviously just calls read on the real repository. The write calls save. The write all loops and calls write, which calls save. The delete deletes, and the delete all loops. Oh, isn't that fancy? Cool. So if I run this now, we should see a nice result. So it saves once. And the reason it's saving once is the coalescing that Alex talked about earlier. It sees, what's happening is, all the writes come in into the write behind, but it's waiting for the min delay. And all 11 views happen before the min delay. They get batched, and it goes, oh, well, you did 11, but I can coalesce. This is all the write to the same key. So I'll just throw everything away, write the 11, I don't need to write the rest. And what I've done is I've reduced the write workload on the database from 11 writes to 1 write. I also haven't ever done a read. The other thing you'll notice while I was talking, it also deleted right at the end. And the delete will be delayed because what happens is the delete comes in and then sits waiting for 5 seconds because that's the max. And it says after 5 seconds, oh, well, you deleted and nothing else is coming for this key. Okay, fine. Let's delete it now. Fire that to system of record and be done.
But the read access that went through the cache, they saw the 1, 2, 3, 4. They saw the
Yes,
values, they saw the delete, because they're all pending, right? We all make that sort of one here on the cache.
Yeah. The cache readers still see every value. Whatever was the current value at that time, you see it correctly. Cool. And obviously, this is a great use for write behind, even if the queue is not persistent. No one cares if you drop a few. No one cares if you drop a few views on a video. It's a nice usage for this. It's also a good usage for Mongo for the same reason. Sorry, that was a Mongo joke there. Cool.
More slides left?
We have more slides left. And how much time do we have?
Not much.
Cool, let's go fast. So we're about to release, we've released M2. M3 is right on the cusp. We wanted to have M3 out before Spring 1. Didn't quite make it. It was partly my fault. I do have an outstanding task on GitHub. It's because I'm here that I didn't get it done. That's what I'm going to say. So let's talk about, am I doing this?
Sure.
Sure, cool. Right. Milestone 4, transaction support. So milestone 3, we're actually working on transaction support in milestone 3. But one thing we want to talk with you guys about is transactions. So I guess I could do this. Hands up if you use transactions in cache, like XA. Cool. We can ditch them. Did you say you did? Sorry.
Not through cache.
Not through cache, but you do use it. So
You
nobody.
realize how more cache uses than the people in this room, right?
Yeah, but this is my sample, so
Okay, cool.
I'm taking
That's
it.
good.
Right, Ludovic's going to love us. No XA, cool. So in 2, we support a full XA resource, which means it's just like a database. We support XA synchronizations. If you know JTA, that's how you're really, in my opinion, that's how you're supposed to plug a cache in. It doesn't work because some transaction managers suck. That's a shame.
Are not optimal. They don't suck.
They're not optimal at not sucking. Right.
Something.
And we also have this thing called local transactions. This is where you don't use XA. You let the cache manager act as a transaction manager, and you can have multiple caches within the same cache manager coordinate in their own little transactional world that's non-JTH. We want to ditch that. We think that if you're just doing caching, there is no reason why you will ever do transactions between caches without having something else outside of caching doing things. We think this is only useful if you're storing things in caches, which is not caching. It's storing. So don't do that. So if you have an opinion on that, or you know someone who has an opinion on that, or you know someone who knows someone who has an opinion on that, please get them to talk to us, because if they want local transactions and they think they have a good use case, and we rip it out, they will never see it again. Then less we can give Ludovic an awful lot of money. Ludovic is the guy that does all this work, because no one else wants to. He's going to hate me when he watches this video. He already hates me anyway. Automatic resource control. Does anyone know what that is? No, they don't, because no one outside of cache calls it ARC. It allows you to size caches in, well, there's 2 things. It allows you to size caches in natural units, i.e. you can size the heap in megabytes. It also allows you to size the cache manager in megabytes. So you can have a cache manager and say, this cache manager uses 2 gig of heap. And we will balance the heap usage of all the caches within the cache manager to stay under 2 gig while attempting to size them according to the load they are under. We would love to know what people think of that, what people think of the APIs for that, how they would like it to be different, whether they think it sucks and it's the worst feature in the world. Beyond M4, don't point down at the microphone. Clustering using the new Terracotta 5 platform. So at the same time as us working on 3, a whole bunch of other Terracotta engineers are working on reworking the entire, reworking the Terracotta platform, reusing what we can, replacing what is no good, fine-tuning the platform for what it now does. It is now all open sourced. It's kind of really open source because bits of it slipped out and have now been pushed back. You can now deploy a complete Terracotta cluster and access it. Totally open source. You can use the off-heap that Alex talked about to back the servers as well. So you can have pretty big clusters. It's a general purpose clustering platform. It backs all of our clustering stuff. It's HA, and you get a configurable consistency model. So you can have strong, or you can relax the consistency as you wish. We are very interested in people's opinions on how you configure clusters and how you'd like to configure the cluster. Obviously, there are some implementation restrictions here, but we'd really be interested in people's opinions on what it's like in 2x, interacting with clustered Terracotta caches, and how you would like to change it. Another big thing that's coming in M4, one of the big problems in caching, particularly for a cache like cache, which covers everything from in-heap to big clustering, they beat us down, is it's the classic problem in Java whereby a heap cache is not the same as a cluster cache. The simple way to think about it is there are far more ways that a big clustered cache can fail. And the question is, what do you do when it does? The kind of cheap way out is to say, oh, well, all the methods throw exceptions. But then the poor guy that's using a simple in-heap cache looks at the API and goes, but every method throws an exception. But what do I catch it? Well, if it's checked, he has to and do something. But the danger is if he catches it and ignores it, and then when he ramps up to doing clustered, he goes, oh, hang on. Now I'm not doing anything with the exceptions and nothing's working because I misconfigured the cluster and nothing works, but I'm swallowing all the exceptions. So that kind of problem we've tried to solve with this resilience strategy. It's this idea that you don't ever catch the exception and handle the error in line. We push it out into a separate strategy. The cache methods will never throw because it's a cache and it shouldn't interrupt your operation, and you shouldn't have to put caching related exception handling in your business logic. You guys already don't see that because it's hidden behind the annotations. But for example, we're of the opinion that the Spring guys shouldn't have to handle exceptions in their caching logic, which you use through annotation. So the idea is the strategy is pluggable, and the EH cache by default will pick different strategies for different deployments. But it will do its best to keep soldiering on if it can, regardless of errors. And if it thinks that something might be wrong config, it will log it. But the important thing is we do not throw things at the user code unless there is no other resort.
And there's also, I think, what the last bullet point says there plays nicely with cache root patterns. So that's our proposal right now for addressing things where, like, you got a cache, it's distributed, right? But you got to give an SLA that you need to meet, okay? As such, you can give the cache, let's say, lookup of, let's say, 100 milliseconds. If you don't get an answer in 100 milliseconds, the clustered storage behind the cache can say, all right, I missed. It can throw some kind of exception. The strategy can understand, says, oh, all right, that's that. Oh, I know what this is. So what I'm going to do is I'm going to let the loader sort of resolve the entry instead. So that if you got an SLA of, let's say, 300 milliseconds, but you would rather be way below that, if for some reason the cache cannot respond in time, you go to your underlying system of record instead, so that you can always meet your SLAs. So that's the way that we plan on going about this. Again, this is probably for milestone 5. Because one thing we didn't mention is EHCache 2x, the API as it sits, was released in 1.0 11 years ago, prior to generics and all that stuff. We tried to never break backwards compatibility for over 10 years. we plan on doing the same thing for 3.0. This is where we're releasing milestones at the pace that we're doing, so we can get feedback. Once we GA, that is again it, right? There'll be more features, but never like backwards compatibility breaking changes again.
We just have too big a community to risk breaking backwards compatibility. It would be too painful. We don't want to ask the community to do the same migration they're going to have to do between 2x and 3 and suffer all that pain every 6 months. It's not fair. So, particularly when it's a library like cache, which you really just want, a lot of people just want to stick in, forget it's there and it does its job. You don't want to have to deal with it. You want to be able to upgrade it and have bug fixes without having to rework everything. So that is the end. And
that is really the end.
That is really the end because we're 40 seconds over time, according to the time. Applause is welcome. Thank you.